consumes a REST API. Hi, I'm Bill Sarur from Dev Mastery, and you're watching Mastery Monday, the weekly show that helps you improve your code and advance your career. Don't forget to subscribe and hit the notification bell so you never miss an episode. In a previous video, we built a web app that let us search for movie posters. Behind the scenes, our app is consuming a free REST API from the Open Movie database. We use test-driven development with Google Puppeteer and Jest. We followed an approach of first make it work, then make it better. The good news is that led us to get to working code very quickly. The bad news is the code is not that pretty. But that's okay, because having working code is extremely valuable. It allows you to confront any potential gotchas along the way, and it gives you a fallback position if a deadline is looming. Once you've got working code, you can go back and refactor and make it better. And that's what we're going to do in this video. Here's our code. On the left-hand side, we've got the tests. On the right-hand side, we've got the code that satisfies the test. And on the bottom, we've got our test runner running continuously to make sure that we haven't broken anything. The first thing that jumps out at me is something that's probably worth changing, is this hard-coded business rule right here. So you see, when we type into our text box, we want to make sure that we've typed at least 3 characters before we enable the search button. And we do that with this little function here. But we're hard-coding that number 3. This rule probably doesn't belong in here. It probably belongs at a higher level or somewhere else inside of our component, because by putting it in here, the only way we can access it is through a sort of a React construct. So at a minimum, I think it's probably worth setting that rule on the text box itself. So we're going to go ahead and do that. Here's our text box. And in here, we can just add a min length. Now we can go back up to our handler, grab the min length, and use it instead of the hard-coded value. And our test still passes. I just realized another problem. We've got some text up here. Enter at least 3 letters from the movie's title. And again, this number 3 is hard-coded. It would be nice to be able to reuse the same value in all places. So I'm going to go ahead and define a constant for minimum movie length. And now we can use that constant in our message. And we can also use it to set the min length of the text box. Let's save and make sure we haven't broken anything. Awesome, still good. The next opportunity for refactoring that I see is in this button handler right here, this click handler. So what's going on here is we're calling our API directly from the click handler. And that's fine if there's only one component that uses this API. But if we imagine that our app has started to expand and that we're using the API all over the place, it's a bit dangerous to be too reliant on knowing the details of the actual API from within all of our components, especially because this is a third-party API that we don't control. So when something changes in the API, we don't want to have to go back and change all of our components or touch every place within our app. Ideally, we could isolate the details about the API into one place and then have our components consume that. So we're going to create what's called a seam. A seam creates some separation between different components within your application. To do this, we're going to step away from our integration tests and move to more traditional unit testing. Inside of our poster search folder, I've created a brand new module called Find Movies. And I've also created a spec, findmovies.spec.js, because we're going to use test-driven development to build it. So with Find Movies, our goal is to create a function that, given a movie title, will return a list of movies. The advantage of having this kind of function is that we can hide away all of the details about working with our API. We just take in a movie title, do all the work of creating an API call behind the scenes, issuing that request to the server, getting back the results, and then when we return the results to our caller, we can actually normalize those results so that the shape of our movie objects conforms to what our app sees as a movie, rather than simply using the representation that's given to us by the server. And the advantage of that is that when things change on the server side, because we don't control the API, we've isolated ourselves from the changes. The only place where we'll have to change our code is inside of this module. The rest of our app that depends on this code will not have to change at all. So the tricky bit, of course, is we're going to have to make a network call inside of this function. And that can be tough to test because network calls are typically slow, and especially in this case where we're actually making a call to an API that we don't own or control, all kinds of unpredictable and unexpected things can happen with that API. So we want to take more control over what's happening. One of the ways to do that is to mock out whatever library we're using to make the API call. In fact, that's what you'll see in the Jest docs. So here's the documentation from the Jest website. They give this example where they're creating a user by calling an API with fetch. And then to test that code that creates a user, they've mocked out their fetch library. And so their test uses the mock in place of the actual fetch library so that they have control over what gets sent and returned. And this works, but to be honest with you, I don't love it for a couple of reasons. One, it sort of encourages you to write tests that are not that useful because the test is simply asserting that your mock works the way it's supposed to work. But you don't want to test your mock, you want to test your actual code. So if you look closely here, you'll see they're mocking the return value, and then they're asserting the return value is the value they mocked in. So that's not very useful. You're just asserting something about the mock you just created. So this test isn't really testing their code. The other thing is if you look at this code very carefully, there are actually a couple of different things going on. Now, this is super simplified, but what's happening here is they're constructing a query that needs to get sent to the API. And they want to test that they've constructed that query properly. So that's what this assertion is about down here. So that's one test. The other thing that they're doing is they're sending back a response, and they want to make sure that the response that's coming back is conforming to what they expect, except as we saw, they're not really testing that because the response is coming from the mock. The other thing is they're just sending the response as is. They're grabbing the text from the actual network response and sending that back. But in our case, what we want to do is we want to control the response. We want to change the representation of our movie objects to conform to what our app views as a movie rather than simply taking for granted that the API is going to return us a consistent representation every time. We want to isolate ourselves from changes in the API. So if you think about it, you can actually divide this into 3 steps. So the first step is create the query. The second step is issue the query. And the third step is format the response. And here they're not doing any of the formatting, but in our case, we will format. So what we're saying is, step 1, build a query based on the user's input. Step 2, issue the query. And step 3, format the result. If we do that, then potentially we can isolate each of these steps into their own functions, which means we can test this function independently and this function independently, and we can actually skip testing this piece because it's not going to do anything. It's just simply going to call out to our library that does the network request. And we already have an integration test that we wrote with Puppeteer that makes sure that all of that is going to work. That might sound confusing at this point, but just stick with me and you'll see how it works. So for our spec, we're going to describe find movies. And we're going to write a test for building a movie query. And then we're going to write another test for normalizing the results of a movie query. So we'll ignore the second one for now by placing an X in front. And we'll start by building our first test. It builds a movie query. So a movie query is basically going to be an object that we pass to our API that does the HTTP request and that contains the parameters that our API, our OMDB API expects. So in our original app, we were using fetch, but I think I'm going to switch to Axios. Axios is an extremely popular HTTP client for JavaScript, and I like using it a lot more than I like fetch. Fetch will do in a pinch, but if I'm going to pick an API library to use, it's going to be, or an HTTP request library to use, it's usually going to be Axios. The other reason that I'm doing this is to sort of show off, because you'll see in the end, our Puppeteer test will continue to work even though we switched from fetch to Axios. So Axios expects an object that has a method, a URL, and in this case it's passing along data, but for us, because we're using query strings, we're going to pass along params. In other words, our test is going to expect something like this. And we'll set a constant for our movie title. And so we'll want to assert that calling build movie query with a movie title of Batman returns that expected object. And if we save this, we should have a failing test. So of course, build movie query is not defined. So we'll need to write that function over in our find movies module. And then we'll need to import it in our spec. Now if we save, we should still have a failing test. Okay, and this fails because we're receiving undefined, of course, since our function isn't returning anything, and we're expecting this object. So let's implement our function. And save, and there we go, a passing test. So let's move on to it normalizes query results. So for this, I'm just going to create a dummy API response that looks like the real thing. And if that's our input, I think I'm going to want something back that looks something like this. And so we'll expect normalize dummy results or dummy posters to equal expected. So let's watch this fail. Okay, we need to export a function called normalize movie results. Save. Okay, now we're failing because we're receiving undefined, so let's implement. Okay, let's save. And voila, passing. So now we need to modify this to handle the case where the poster is missing. So our API returns an NA when the poster is missing, but I think we can do something a little more elegant. So we'll just expect a missing poster to just be null. And we'll save this and watch it fail. And then we'll implement. And we're passing again. So next we'll handle the case where there are no results. And so 0 results from our API looks like this. And we want to translate that to something like this. And so we can assert that our normalized movie results for 0 results returns that expected result. Okay, let's save and watch it fail. And so of course our results object doesn't contain a search property, so it's failing on that. No problem. Let's jump in and implement. And we'll save. Great, passing test. Next we'll handle other API errors. So an API error looks like this. And we'll just expect an object that just contains the error. Let's watch it fail. And we'll implement. We save, and back to green. Okay, so now we need a function that ties it all together. And before we implement this, we'll wire it up to our component and watch our integration test fail. So back in our UI component, we can import our find movies. And in our click handler, we'll remove fetch and replace it with find movies. And now our integration test should fail. And sure enough, everything is broken. So let's go and start to implement. We'll need to import Axios. And we'll build our query, pass it along to Axios. Catch any errors. We'll just console log for now. And we'll throw a generic error. So our tests are still failing because we're not consuming the new shape of our response. So let's fix that. And we'll save. Still not working because we're depending on the original API shape down here. Save again. Right, because we're passing in search still, so this needs to be movies. Now we'll save. And everything works. So we can check the app for ourselves just to make sure. Looking good. So of course, there's always more refactoring we can do. For example, this find movies function is now a pretty good candidate for what's called pipeline style programming, because all it is you're piping the result of one function into the next, into the next. I'll put a link in the description to my video on pipeline style programming, and maybe you can download the code yourself and see if you want to try it. That's it for this week. See you next Monday.